In this section, 4.3 logarithmic functions, we begin looking at logarithms. Logarithm is simply another way to write an exponent. A logarithm is really an exponent. If we have an expression, I want to zoom into this here and show you that this is what we're going to be using for many of the problems in this section. In exponential form, we have a base b raised to a power t equals r. We can rearrange the three parts of an exponential equation and write it in logarithmic form. Logarithm is an exponent, b is the base, r is the argument. So we call this log base b of r equals t, where t is equal to the exponent. B is the base, r is the argument, and t is the exponent in both exponential and logarithmic form. So anytime you have an equation that's written in exponential form where you can pick out the three parts, you can rearrange it into logarithmic form. So the equation 3 to the fourth equals 81 for this example is in exponential form, and we want to rewrite it in logarithmic form. Log is actually the letters log is an abbreviation for logarithm. Anytime you have a logarithm, you're going to write it as a base, an argument, and an exponent. The log on one side is always equal to the exponent on the other side. So what we have here, 3 is our base, the base 3. 4 is the exponent. And then finally 81 is what we call the argument. Got to give it a name, so let's call it an argument. We can now rewrite this 3 to the fourth equals 1 as log base 3 of 81 is equal to the exponent 4. Think about 3 to what power gives you 81? The logarithm is simply asking for the exponent. 3 to what power gives you 81? That power is 4. So we can write this in MyMathLab. The log and the base 3 are already written, so we're going to write the argument 81 equals 4. Okay, keep this, write this down, look at it daily until you can easily go from one form to the other. Let's look at number 2. Number 2, again, we have the equation written in exponential form, and we want to convert it to logarithmic form using these properties here. Let's make this a little bigger and see if we can pick out the three parts. The first part is the base. Okay, the base b is equal to 5/3. So b is equal to 5 over 3. That's our base. The exponent t is -3. T is equal to -3. And then the other part we have is the argument. That's going to be our 27 over 125. So the logarithm can be written as logarithm. The base is log base b of the argument, which is blue. That has to equal the exponent t. So we can now write it as log. The base is 5 over 3. The argument is 27 over 125. And the exponent equals -3. We want to compare these. It looks like out of all those choices, the second one is the correct answer. Let's look at number 3. We want to convert to an exponential equation. Here we start off with a logarithmic equation, and we can go backwards. We can write it as an exponential equation. If we pick out the three parts, the base is b. Again, the base is 4. B is equal to 4. That's our base. The exponent is 2. T is equal to the exponent 2. And then the argument r is equal to 16. Log base 4 of 16 equals 2. That's the same thing as saying the base of 4 raised to the power of 2 equals 16. Again, we want to write b to the t equals r. The base of 4 raised to the exponent 2 has to equal the argument 16. Just a way of rewriting a logarithmic equation into exponential form. Check our answer. Okay, so as you can see, we can go from exponential to logarithmic form, and we can go from logarithmic form to exponential form. Let's continue looking at number 4. Write the statement in its equivalent exponential form. Here we have log, and the base is the square root of 3 of 81 equals 8. Pick out the three parts. The base. The base is always slightly lower than the word log. So b is our base, square root of 3. Find the exponent. The log on one side always equals the exponent on the other. T, that exponent is equal to 8. And then finally the argument, r, is equal to 81. This is in the form of log base b of r equals t, and we want to write it in exponential form, taking the base b to the exponent t has to equal r. So the base square root of 3 raised to the exponent 8, that is going to equal 81. Let's check our answer. Square root of 3 raised to the power of 8 has to equal 81. And check our answer. Okay, let's look at number 5. Number 5, you have an equation and you want to solve the equation. And we can do that by taking the logarithmic equation and converting it to exponential form. Okay, we want to identify the base. Here we have x equals log base 2 of 1 over 16. This is the same thing as t equals log base b of r. We're using that equation here. B is the base. The base b is equal to 2. It's a number right next to the log. It's a subscript, base of 2. T is the exponent, is equal to x. And then finally the argument, r, is equal to 1 over 16. So we're going to rewrite this logarithmic equation into exponential form. In exponential form, it's the base raised to the exponent equals the argument. B to the t equals r. Plugging in what we know, the base is 2 to the x power equals 1 over 16. Now this is one of those exponential equations that we did in section 4.2. 2 to what power will give you 1 over 16? Well, this 1 over 16 is the same thing as 1 over 2 to what power gives you 16? That's 2 to the 4th power. And 1 over 2 to the fourth power is the same thing as 2 to the negative 4. So if you have an equation now that can be written as 2 to the x power equals 2 to the negative 4 power, then if you have an equation where the base on the left equals the base on the right, then you can drop the bases and say the exponent on the left has to equal the exponent on the right. So we can say x has to equal negative 4. And we can check our answer. So the key in solving these logarithmic equations is identifying this relationship between a logarithmic equation and an exponential equation. If each one has 3 parts, they're just rearranged in each one.